Hi guys, welcome to the lesson of partial differential equations. So we discussed about the classification of second order partial differential equations having two independent variables and having more than two independent variables. So in today's lecture, we are going to discuss canonical forms of partial differential equations of order 2, right? So what is the purpose of transforming the partial differential equations into canonical form is to transform the equation from a complex form to a normal form from where we can find the solution easily by making the equation separable or solvable, right? So here, if we are given with a function of two independent variable, you can see that use a function of f of x, y. So we are using the transformation uh, we are using a function psi that is a function of x and y, and function eta that is also a function x and y. Then this u will be transformed from x, y to this psi and eta, right? So what we will get at the end will be a function, u will be a function of psi and eta, right? So here we go. So the conditions for transformation are, number one thing is that the function psi and eta are continuously differentiable. What does it mean? It means that the derivative exists and it's continuous, right? So when we keep on differentiating, we should get the derivative, and the derivative should also be continuous, right? And the second condition is the Jacobian should not be equal to 0. So when we will choose psi as a function of x and y, and then eta as a function of x and y, we will see in the latter part that how to choose these. So what we will do is we will differentiate this psi function partially with respect to x and y, and then this eta function with x and y, and then put it in the determinant of the Jacobian, and we will see that this is equals to 0 or not. If it is equals to 0, then the condition fails. If it's not equal to 0, then we can follow our solution, right? So what is the basic idea behind this transformation is we are going to use the chain rule. When we are saying that psi is function of x and y, psi is a function of x and y, and eta is a function of x and y, then we are actually transforming this function u of x, y to the function of psi and eta, right? So here is the procedure. That is now the ux, that is derivative of u with respect to x, will be equals to dawa u over dawa psi multiplied by dawa psi over dawa x plus dawa u over dawa eta times dawa eta over dawa x. This is how we write the partial differential equation using the chain rule when we are transforming a function into two other functions, right? So now we are saying that this x is depending on psi and eta. So this again, now for ui, we will do the same thing, but now it will be dawa u over dawa psi into dawa psi over dawa y plus dawa u over dawa eta into dawa eta over dawa y, right? So we can write like this. Now when we will apply the derivative again with respect to x, so the function will become like this. Use when we will apply again derivative onto this equation, that is we want to find uxx, so we have to differentiate partially this whole equation. So what you will get is u of psi times psi x squared, where the psi x represents the function's partial differential equation, partial derivative of the function psi with respect to x, then plus u times psi eta. That means that first we have differentiated with respect to psi and then with respect to eta, right? And then psi of x again means the partial differential derivative of the function psi with respect to x, then times eta x plus u eta eta times eta squared x plus u psi double x plus u eta and eta double x. So you need to remember this equation for future use, right? So in the similar manner, we are going to find uyy. So uyy is again the uh, derivative of this uy. We are differentiating this uy again with respect to y. So what we are getting is u psi times psi squared y. Again, this psi y shows that this is a partial derivative with respect to y, then plus u 2u psi eta eta, then psi times psi y eta y plus u eta 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 squared y plus u psi double y plus u eta eta double y. So you can see the similarity between these two. What is the similarity? There's that these terms are same in both the equations, so you can remember this easily. Only what is changed here is psi x, here is psi y, right? Here is psi x, eta x is psi y, eta y, right? So only the change is this x and y, right? With the function of psi and eta. So it's easy to remember this equation, and you can figure out like this is u psi then plus 2 u psi eta then plus u eta eta, right? It can be figured out easily. It's not a difficult task. Or you can remember like that, this is the second derivative of u with respect to psi, then uh, the derivative of psi u with respect to psi times the derivative of u respect to eta, and then the second derivative of u with respect to eta, then the first derivatives of psi and eta, sorry, u and eta with u with respect to psi and eta, right? So these are the first derivatives of u with respect to psi and eta, right? So in the same manner, and then we will find uxy. So what's uxy? Uxy is simply that you are differentiating this ux now with respect to y, partially differentiating this ux with respect to y. It means that you are doing dawa over dawa y times dawa u over dawa x, right? So what you are getting is this equation uxy. So this is again u psi, u psi eta, u eta eta, u psi, u eta, right? So and here it's the multiple of psi x and psi y. It's the product of the first derivatives of both psi x, psi y. And here eta x, eta y, and the similar manner here it's xy. It means that we have differentiated this psi function with respect to x first and then with respect to y, right? So this is the general idea of these derivatives and this chain rule. So first of all, we will talk about the hyperbolic partial differential equations. We discussed how to classify the hyperbolic equations. We just need to find the discriminant, that is b squared minus 4ac. And if it's greater than 0, then we say that this is a hyperbolic partial differential equation of order 2, right? So then the characteristic equation is given by this form dy over dx. So once you found that this is a hyperbolic PDE, then you can apply this form easily. Dy by dx is equals to b plus minus square root of b square minus 4ac over 2a. And we will see in the problem that how we will apply all these uh, phenomena, right? So now let's take a problem. We are given 3uxx plus 10uxy and 3uyy is equals to 0. Now this problem seems complex problem to solve, but what we will do, we will transform this problem and we will make it very confined, right? Transforming into the canonical form. So what's a here is the coefficient of uxx, What's b? It's coefficient of uxy. What's c? It's coefficient of uyy. So we will apply the condition of b squared minus 4ac, and we will see that it's greater than 0. 10 squared minus 4 times 3 times 3. So it's 100 minus 4 3s are 12 and 12 3s are 36. So it will be 64. That is greater than 0. So it's hyperbolic, right? So now we can apply the characteristic equation, and here it's b, and b is 10, right? So 10 here plus minus, then b squared is 10 squared, or you don't need to find, because in this step we already find that this discriminant is still 64. So it will be square root of 64 divided by 2 times a, and a is 3 in this case, right? So now you can see that after simplifying, dy over dx is either equals to 18 over 6, or dy over dx is either or equal to 2 over 6, because of this minus and plus. So we will get two roots from here, and now you can see that this is equals to 3, this is equals to 1 over 3. So it's easily integratable. It's a separable equation. So we integrate, and we found that y is equals to 3x plus c1. Right, so similarly, by integrating this equation, we get y is equals to 1 over 3 times x plus c2. Now the very important step is that you have to find c1 in terms of y and x, right? So you have to isolate this c1 onto the left hand side and this c2 onto the left hand side. Once we found the function, we will just transform. Now we will say that this psi is equals to y minus 3x instead of this c1. We are saying that this is a function because we can see that this is a function of x and y. Y minus 3x is a function basically of x and y. Then we are calling that, let's say that this function of x and y is equal to some other function, right? And similarly here, we also said that this eta is equals to y minus 1 over 3x. Now we will do the procedure for finding ux, uxx, uyy in terms of these psi and eta functions. So first of all, we will find this psi x. That is the partial derivative of psi with respect to x. So it's minus 3, because when we differentiate with respect to x, this will be 0. And from here, we will get minus 3, right? By differentiating with respect to x. And then psi y will be 1. This will become 0 for this part. And this y will get, the derivative of y will be 1, right? Similarly, for eta x, when we differentiate this function with respect to s, we will get minus 1 over 3. And when we differentiate with respect to y, we will get 1. Right? Similarly, psi xx will be 0, because when we'll differentiate this constant, so this will become 0 again. Eta xx will be 0 again, because eta x is constant. Psi yy will be 0, because psi y is a constant. Similarly, eta yy and all these will become 0, right? Because we are differentiating constant functions. So what we call that in the initial step, that ux is equals to u double psi, if you can, sorry, ux is equals to, here we can see that ux is equals to dawa u over dawa psi, which we can write as u psi. This dawa u over dawa psi refers to u psi. We can write dawa u over dawa psi as u of psi, right? This simple notation for this part, that dawa u over dawa psi can be replaced with u psi, and you already know this, right? And similarly, this dawa u over dawa eta can be replaced by only u of eta. So here we uh, uh, did that u psi times, here it was psi x. So we put the value of psi x, that is found to be -3, and here is u eta times -1 over 3, right? What we are doing in this step is we are just putting the values of psi x and eta x into this equation, right? Ux, this equation ux, right? Because in the question, we are given uxx, or if you don't, if whether in this question, in fact, it's no need to find ux, because in the question there is no ux, right? There is no ux in the question. You can see that it's u double x. So we need to find only these three elements, that is u double x, uxy, and uyy, right? So you can directly apply the equations of uxx, uxy, and uyy. So uh, these are the equations. These are the equations of uxx, uyy, and uxy, right? So we are directly now, just what we are doing is we are putting the values of these functions, right? Yes. So it's psi square x, right? So we are putting the values of these functions, right? These functions, these functions in the equations, right? And these will be remain as it is. These will remain as it is, right? So in the part of uxx, we are just going to put that we don't need to find this ux, right? Because we don't need ux in the equation, original equation. So uxx will be equals to u psi psi times minus 3 squared plus 2u psi eta times minus 3 times minus 1 over 3 plus u eta eta times negative 1 over 3 whole squared, right? We are here. So we are discussing this equation. So plus u eta eta times negative 1 over 3 squared. Negative 1 over 3 squared is actually what? It's eta x whole squared, right? And this will be 0 because this function is 0, right? So here it's in the product form, so it will make it 0. And similarly for uyy, we will put the values of psi y, eta y, and this will be 0 because of these are 0, right? And then for uxy, here it's psi x times eta y, psi x times eta y, then eta y times, sorry, eta x times psi x. Sorry, it's eta, let us see in the equation. It's psi x eta y plus, here this is the part, psi x eta y plus psi y eta x, right? So psi x eta y plus psi y eta x, you can see here, right? Then plus this u eta eta times negative 1 over 3 times 1, then these will become 0 because these are 0. And then once we found these uxx, uxy, and uyy, we just need to put in equation number 1. That is our question, right? That is the question, basically. Equation 1 is the question. So we will replace the value of ux. So it was 3 times ux, so we'll replace ux, all right? And then it was plus 10 times uxy, so we'll replace uxy, and it was 3 times uyy. So we replace all and we'll now simplify. It will be 3 times 9 will be 27 u psi plus 6. 3 times 2 is 6. So 6 u psi eta plus 1 over 3 u eta eta minus 30 times u psi plus 30 times u psi eta minus 10 over 3 u psi eta minus 10 over 3 u eta eta plus 3 u psi plus 6 u psi eta plus 3 u eta eta. What we did is we just simplified this equation, right? So we get this 1027 u psi plus 3 u psi will be 30 u psi. Then we have negative 30 u psi, so we write negative 30 here. Then negative 3 u eta eta. We'll add these all u eta etas. So we will get negative 3 eta eta plus 3 u eta eta. So this will cancel out also, and then we will add up all these psi etas, right? Psi etas. So we will get negative 64 over 3. So all of this cancel out, only we are left with negative 64 over 3, and negative 64 over 3 times u psi eta, sorry. So we are left with only this part, right? So we can move this 64 over 3 to the right side, it will be 0. So we found the final form, that is the canonical form for this equation, that is u psi eta is equals to 0. And you can see that now from this equation, we reduced and we are only left with this one, right? And it's easily solvable. It's a separable equation basically, right? So we can integrate this with respect to eta first, and then with respect to psi we will get easily the conclusion, the answer, right, in terms of function of psi and eta. So here you see how to transform the given differential equation to the canonical form, right? So now we'll take another question. Let's say that this is the question, right? The question is x, phi, xx. So you don't need to be confused with this phi xx. Here it's simply phi is a function of x and y, right? So it can be anything. It can be z. We can also represent it by z, or we can represent it by theta or anything, right? So procedure is same. We are not going to be confused with it. X phi xx plus 2x squared phi xy minus phi x is equals to x cubed, right? So we will check that either it's hyperbolic, parabolic, or elliptic PDE, right? So to apply, check that, we will apply this form, that is b squared minus 4ac. So here a is the coefficient of phi double x, b is the coefficient of phi xy, and c is the coefficient of phi yy, but phi yy is absent, so it will be zeros, right? So you can see here, right? We will apply to the equation, then we will found that b square minus 4ac is 4x power 4. So we know that x power 4 cannot be negative, right? It cannot be negative. It will always be positive because if the power is even, so whatever constant is inside, either is negative or positive, it will make it positive because of this even power, right? Then we know that once we are done with this part, then we know that for the hyperbolic equations, the characteristic equation is this: dy over dx is equals to b plus minus b squared minus 4ac over 2a. We applied the form and we found the two curves, right? So two independent curves. So we can integrate because it's separable, easily integratable. What we get is y is equals to x squared plus c1 and y is equals to c2. So here again, what we will do, we will write this as a function of c1 as a function of xy. So it will be equals to y minus x squared. Then we will replace this c by psi, c1 by psi, and this c2 by eta, right? So actually we are transforming in this step, right? So here's the transformation. And then again, the similar step, that is to find psi x, psi double x, psi xy, psi x, eta xy, eta xx, and all these functions, right? And derivatives. So we can see that psi x will be negative 2x. Why? Because when we differentiate this function with respect to x, so we will get negative 2x, right? So phi xx, again differentiating this, we will get negative 2. And similarly all these stuffs, right? So after that we are going to put into the equation of phi x, phi xx, phi xy, and all this stuff. So what we need is, we need only these three, because in the question these three are given, right? So we need these three only. So we will find these three. So phi xx is equals to phi of psi times psi x, that is negative 2x, plus then phi of eta into eta x, that will be 0 because eta is only a function of y, you can see here, right? So eta x will be 0, right? Because eta is a function of y only. Then we will find phi xx. For that we have equation phi double psi times psi x squared plus 2 phi psi eta times psi x into eta x, that is 0. I've written here it's 0. All this what is 0 will create, it will make these from 0, right? Then again we'll find phi xy. Similarly, after getting phi xy, we will put in equation number 1, that is the question, given question, right? So here we go, you can see that the question was x times phi double x. So here is phi double x, then plus 2x squared times phi xy. This is phi xy plus 2x times, it was let me check, it's negative phi x, right? It's negative phi x. So what's phi x? So we can see that phi x from here, it's negative 2x phi psi, right? So we can write instead of phi x. So here we write and x cube as it is. We will simplify. So these will cancel out, right? This with this with this, and we will only left with these two terms, right? So here we write these two terms, and x cube is common, so we can take out common with negative sign. So it will move to the right and it will become 0, and we will left with 4 phi psi eta plus 1. So you see how cool is that? So we have transformed the given equation that was initially seems to be complex, but now we are uh, feeling easy for solving this equation because we can just write this in this manner, is equals to negative 1 over 4, and then we can integrate this function first with respect to eta and then with respect to psi. So we will easily find the solution from here, right? So this is the canonical form, and that was our main objective, right? So hope you guys will learn from this lesson, and I tried to solve some problems. I solve a variety of problems. First I take problem of constant coefficients, then I take a problem on variable coefficients, and I showed how to solve both type of problems and how to reduce them to the canonical forms, right? So best of luck and goodbye till the next lesson. Thank you for watching.